Hello, my name is Aryan Garvi, and I'm going to present on this topic home automation system. Uh, I'm currently pursuing my DY BSc degree from Narsimhanji College of Commerce and Economics. So first of all, thank you EmertXE for providing such good internship for our students in order to learn and experience this great event. Thank you. So let's begin. So topics to be covered. So what are all the topics to be covered in this PPT? Firstly, introduction to C and C++, introduction to embedded systems, introduction to Internet of Things, then what is a problem statement of the project, tool used to implement the project, what are the technologies which we have used for the implementation, then peripherals requirements, and then finally the output of the project. So let's start with introduction to C and C++. Introduction to C. A C is a general purpose programming language which is designed to be used across a wide variety of application domains, not limited to a specific problem or area. C fits this description perfectly as it can be used for everything from operating systems and embedded systems to desktop application, network programming, and even games. Example, C is used to write operating system like Unix, and its influence is seen in many other modern operating system. It also used in developing embedded systems like microcontrollers due to its low level access to memory and hardware. Then second is it is free formatted language explanation. A free form language is one where the positioning of character on the page is generally not significant. In C, white spaces like spaces, tabs, new lines is mostly ignored, except when separating tokens. This gives programmers flexibility in formatting their code. Then its efficiency. Then, for example, the int main print f hello world return 0. The above code could also be written like this: int main print f hello world return 0 in one line. Both version of the code do the same thing, but the format is different. Third, efficiency and portability. C is known for being close to the machine level, meaning it can be highly optimized by the programmer and compiler for performance. C program are often very fast because they allow fine-grained control over system resources. Portability. Despite its efficiency, C is also portable, meaning that with minimal modification, C code can run on different types of hardware and operating system. This is one of the reasons why C has been so widely adopted in different domains. For example, let's take the sample C program can compile and run a variety of systems such as Windows, Linux, or even microcontroller with little to no change in the source. So, uh, the libraries facilities plays an important role. This libraries makes it easier to develop software because this they provide reusable code, thus saving time and effort. Example, the C standard library include function like printf for output, scanf for input, malloc for memory allocation, and strlen for string length calculation. By using this library, developer can focus on the unique part of their application without worrying about implementing basic functionality from scratch. Each of these features makes C a powerful, flexible, and widely used programming language, particularly suited for application where performance, control over hardware are critical. So this were the introduction to C. So what we have learned apart from this is like C has basic data types, and then we have learned about the number system, data types, operators, different types of operators, how to implement functions, then pointers, and many more. So this is a typical C code content which contains a documentation, preprocessor system, global declaration, the main code, and the main code contains the local declaration, program statement, function call, one or many function, the function body. Okay, this is the template code content. A typical code might contain the blocks shows on left side. It is generally recommended to practice writing codes with all the blocks. So there are different types of operators like arithmetic, then logical operator, then assignment operator, and many more. So let's begin with introduction to C++. C++ is an object-oriented language, a powerful general-purpose programming language developed by Jan Stroustrup as an extension of C. It supports both procedural and object-oriented programming paradigms, making it versatile for various type of software development from system software to application. Let's talk about C++. Let's talk about the difference between C++ and C. A procedural programming language that focuses on function and the sequence of steps to solve a problem. It provides low level access to memory and is often used in system programming. C++ extends C by adding object-oriented feature, allowing developers to create classes and objects, encapsulate data, and reuse code more efficiently. While C focuses on procedures, C++ emphasizes data and the operation that can be performed on data. Key differences like object oriented C++ support classes and object while C does not. Then C++ allow multiple function with the same name but different parameters. Then C++ has feature like constructor, destructor and dynamic memory allocation which are not present in C. Standard template library. C++ provide a rich library of template for common data structure and algorithms, which C lacks. Concept of object-oriented programming. A programming paradigm centered around objects and classes, which are blueprint that define attributes and behavior. OOP promotes code organization, reuse, and scalability. Then fourth, let's talk about pillars of OOP, like abstraction, encapsulation, inheritance, polymorphism. These are the pillars of object-oriented programming. So let's talk about abstraction. Hiding the complex implementation details of a system and exposing only the necessary feature. It helps reduce complexity by focusing on what an object does rather than how it does. For example, a car object can have an abstract meta drive where the implementation detail of how the car starts, accelerates, and move are hidden. Then let's talk about encapsulation. Bundling data, attributes, and method functions that operates on the data into a single unit or a class, and restricting access to some of the object's components. This is done using access specifiers like private, protected, and public. Example, for let's take for example, in a car class, the speed attribute might be private, with public method accelerate and brake to control it, preventing direct access to speed. So then comes inheritance, a mechanism where a new class inherits properties and behavior from an existing class. It promotes code reuse and establishes a hierarchical relationship between classes. Let's let's take an example. A vehicle class can be the base class with car and bike as derived class that inherits common attributes like wheels and method, like start engine and all. So polymorphism, the ability of different classes to be treated as instances of the same class through inheritance. It allows objects of different classes to be accessed through the same interface, typically via method overriding and method overloading. For example, a base class shape with a method draw, derived class circle, rectangle, and triangle override the draw method. When a list of shapes object is iterated, the correct draw method for each shape is called, even though the method name is the same. Then C++ feature. It contains C++ is a strongly typed language, ensuring that operations are performed on compatible data types. Then it contains overloading. C++ supports function overloading. Same function name but different parameters. And operator overloading. Customer behavior for operators like plus, minus, etc. C++ allow generic creating generic functions and classes using templates, enabling code reuse for different data types. Exceptional handling. C++ provide mechanism to handle runtime errors using try, catch, and throw blocks. Then dynamic memory management. C++ also contain dynamic memory management includes operator like leave and delete for dynamic memory allocation and deallocation. Then a rich library of generic classes and functions to handle common data structures and algorithm, which is a standard template library it contains. Then what again the features like virtual function and classes virtual functions. Function is a base class that can be overridden in a derived class. When a base class pointer points to a derived class object, the derived class version of the function is called, enabling runtime polymorphism. For example, in a shape class, draw can be declared as virtual if circle and square override draw. The correct function is called based on the object type at runtime. Then it contains virtual classes. C++ doesn't have a direct concept of virtual classes, but it support virtual inheritance, where a derived class can inherit from a base class virtually, preventing multiple instances of a base class when using multiple inheritances. For example, if A is a base class and B and C inherit from A, then D, which inherits from both B and C, will have only one instance of a due to virtual inheritance. So these are the C++ feature. Then let's talk about introduction to embedded system. Embedded system is basically a specific system which has a combination of both hardware and software and which are intended to do a specific task. That this they are called as embedded system. So getting ahead, we have learned about the components. What are the components of embedded system? This diagram appears to represent a high level overview of an embedded system or a system on chip architecture commonly found in various electronic devices and systems. Component and their function, that is microcontroller, system on chip, microprocessor, core processing unit. This is central components of the system that controls the entire operation. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. It typically contains a processor, memory, and input-output peripherals. System on chip. A system on chip integrates all components of a computer on other electronic systems into a single chip. This includes the CPU, memory, input-output ports, and secondary storage. Then let's talk about a microprocessor. A microprocessor is a general purpose central processing unit used in computers and similar devices. Then what are the memories? The component stores the program code and data that the microcontroller or processor need to execute tasks. It can include RAM, which is volatile memory, and ROM or flash, that is non-volatile memory. Then it contain FPGA, Field Programmable Gate Array, and ASIC, Application Specific Integrated Circuit. Customizable hardware logic. FPG, a semiconductor device that can be programmed after manufacturing to perform specific hardware function. It's often used when flexible hardware configuration is needed. ASIC is a chip which is designed for a particular application or a specific use case, offering better performance and efficiency compared to general purpose chips. Digital to analog converter. Digital to analog converter is basically is a interface for it is used to convert digital to analog signals. Then actuators. Actuators convert digital signal from the microcontroller processor into analog signal that can control actuators. Actuators might include motors, lights, or other mechanical components. ADC, interface for sensor, converts analog signal from sensor into digital data that can be processed by the microcontroller or processor. Sensor could measure temperature, pressure, light, or other environmental variables. Then actuators are the output devices. These are mechanical devices or systems that take the control signals from the DAC and perform a physical action such as moving a motor, opening a valve, etc. Sensors are basically a ADC and actuators are DAC. So sensors then again sensor detect environment changes or condition and send analog signal to the ADC for the conversion of digital data that the microcontroller or processor can process. Then human interfaces, user interaction. This include devices like button, touchscreen, displays, or keyboard that allow user to interact with the system, or basically it is used for communication. The microcontroller process this input to perform the desired task. Then we have diagnostic ports. Maintenance, and it is used for maintenance and debugging. This port allows for external tools to be connected to the system for monitoring, debugging, or updating the system software. It's critical for troubleshooting and ensuring the system operates correctly. So these were all the components which are used in embedded systems. So what then, let's talk about IoT, Internet of Things. Let's go to the introduction. The Internet of Things is a transformative concept where everyday physical objects are connected to the internet, enabling them to contact, enabling them to collect, share, and act on data without human intervention. This interconnected network of devices, often referred to as smart device, forms a complex ecosystem that allows for unprecedented level of automation, efficiency, and insight. Then unique objects connected to the internet. In IoT, things can be any physical object embedded with sensor, software, and other technological that allows it to connect to the internet. These objects can range from household appliances, car, industrial machines to wearable devices, all becoming part of the vast interconnected network. Then devices, not people. Unlike traditional internet usage that revolves around human interaction, IoT emphasizes machine to machine communication. Devices communicate with each other autonomously, often with minimal or no human input. This shift from human centric to device centric communication is what makes IoT distinct. Then it contains bidirectional communication. IoT devices are capable of both sending and receiving data. This bidirectional communication allows devices to not only report their status or data back to a central system, but also to receive instructions or update, enabling real-time responses and adjustment. Then IoT contains a large complex data flows. The massive number of connected devices in IoT generates an enormous amount of data. This data flow is often continuous and complex, requiring advanced processing and storage solution. Managing, analyzing, and deriving value from this data is one of the key challenges and opportunity in IoT. Then what are let's talk about the challenges for the IoT. The widespread adoption of the Internet of Things has brought numerous benefits, but it also presents several significant challenges. These challenges must be addressed to fully realize the potential of IoT and ensure the system are secure, scalable, and efficient. Addressing. Addressing as the number of IoT devices grows, assigning unique addresses to each device becomes a complex challenge. The traditional IPv4 addressing scheme, which provides around 4.3 billion unique IP addresses, is insufficient for the vast scale of IoT solution of IoT. Then scale. IoT network can consist of millions or even billions of connected devices. Managing such as a large number of devices, ensuring that operate correctly, and maintaining the network's overall performance are major challenges. Then what can be the solution? Like scalable IoT platform and cloud services are required to handle large scale deployment. This platform must support automated device management, robust security measures, and efficient data processing to accommodate the growing number of devices. Then connectivity. Connectivity, IoT devices need reliable and continuous connectivity to function correctly. However, ensuring consistent connectivity across diverse environment and handling and is challenging because handling various types of networks, Wi-Fi, cellular, LW, low rate wireless area network is challenging. Then then let's talk about data volume. IoT generates massive amount of data, often in real time, storing, managing, and analyzing this data in a timely manner is a significant challenge, particularly when it comes to ensuring data privacy and security. Uh, though these were the challenges. which were faced by IoT. So let's talk about the problem statement of our project. So home automation system. What is the objective? Design and implement a home automation system using the Pixim Lab simulator for the hardware simulation and the Blink IoT mobile application for remote control. The system should enable user to manage various aspects of their home environment through the Blink app, which is a cloud app, IoT based cloud app. So components and functionalities like lights control, then feature user should be able to turn lights on and off from their mobile device, simulate a light control system in Pixim Lab, use a relay or transistor in the simulation to control the on-off state of the lights, provide a button widget in the Blink app to toggle the lights. Users should be able to monitor and control the temperature of the home, simulate a temperature sensor in the Pixim Lab, then connect the sensor to a microcontroller that reads the temperature data. Blink integration, display the temperature reading in real time on the Blink app, provide a slider or input field for user to set a desired temperature and use this control and actuator. So we can also control and monitor the inflow and outflow of water in the tank. The implementation will be done like simulate water level sensors and actuated in Pixim Lab. So these are the problem statement. The home automation should be simulated on the Pixim Lab simulator. Blink IoT mobile application used to control these devices should be able to control the light, temperature of the home, and inflow and outflow, which is inlet and outlet valve of water in the water tank. So the tools which are used to implement this project are PiximLab, Arduino IDE, Blink IoT, and Virtual Serial Port tool. PiximLab. PiximLab is a simulation tool used to emulate the behavior of microcontroller such as the Arduino Uno in a virtual environment. Functionality. It allows you to create and test circuits, write and debug code, and observe how your hardware will behave without needing physical component. Then you will use PiximLab to simulate the Arduino Uno and other components of your home automation system, allowing you to test and validate your design and code. Then Arduino IDE. Arduino is an open source electronic platform based on easy to use hardware and software. It provides a range of microcontroller boards and a development environment for writing and uploading code to this board. Arduino board can interact with sensor, actuator, and other components to perform various tasks. Then you will write code for the Arduino Uno microcontroller to control the lights, temperature, and water tank in your home automation system. This code will be tested and simulated using PixinLab. Then the Blink IoT. Blink is a platform that enables you to build and manage IoT applications. It includes a mobile app for Android and iOS and a cloud server for communication. It provides widget that can be used to control and monitor IoT devices via mobile app. So this is an intermediator between the mobile app and the controller. This widget can interface with your hardware through the Blink server. You will use Blink to create a mobile app interface that allows user to control and monitor the various aspects of the home automation system remotely, such as light, temperature, and water tank level. Then let's talk about virtual serial port. So this is a software tool that creates virtual serial port to simulate serial communication between devices, which will be used for the serial communication for serial water tank. They allow you to create virtual serial connection that mimic physical serial ports, enabling communication between different software application or between software and virtual hardware. You will use virtual serial port tool to establish serial communication between the PiximLab simulator and the Blink app or other software. This helps in testing and debugging the interaction between your simulated Arduino hardware and the mobile application. By leveraging these technologies, you can create a robust and interactive home automation system that can be tested and managed both virtually and in real world scenarios. So, what are the basically let's talk about the project requirements. So, project requirements. Then read the LED sensor value based on the reading from LDR. Vary the brightness of the LED, which resemble control garden lights based on the availability of the sunlight. Simulate garden lights that automatically adjust their brightness based on the availability of sunlight. Then the components used which are LDR, which is a light depending resistance. We We will see ahead about that, the how it looks like or how it works. Measures ambient, it basically measures ambient light levels. Then we have used LED represent the garden for representation of the garden light. The higher the resistance, lower the brightness, and then uh, less the resistance, higher the brightness. It will work like that, the LED and the LDR. Then we have then LDR adjusts the brightness of the LED accordingly. When sunlight is abundant, the LED should be dimmed, and when it's low, the LED should brighten, mimicking garden lights, adjusting based on sunlight. Then temperature control system. Manage the temperature of the environment by controlling a cooler and a heater based on temperature reading. The components which are used is LM35. The temperature system itself contains that LM35. Measures the current temperature. Cooler and heater are the devices to regulate temperature. Then Blink IoT app provide user control and display temperature data. Read temperature data from the LM35 sensor. Use the Blink app to control the cooler and the heater. Cooler turn on or off based on user input from the app. Heater, it will automatically turn off if the temperature exceeds 35 degrees Celsius to prevent overheating. Then it will display the current temperature and temperature gauge in the Blink app, which is implemented or which is a widget, which is one of the widget in the Blink IoT app. Then we will do the water tank management, controlling the inflow and outflow of water in a serial tank to maintain optimal water levels. The components which are used are inlet and outlet valve. Then controlling the water flow. Water level sensor measures the volume of water in the tank. Then Blink IoT app will provide control button for valve management for inlet and outlet, which is done by button widget. The functionality like it uses button widget in the Blink app to control the inlet and outlet valves. Inlet valve will turn on or off based on the user input. Outlet valve will also do the same, which is based on the user input. Automatically manage the water levels, automatic filling. If the water volume falls below 1000 liters, it will automatically activate the inlet valve to fill the tank. Tank full detection. If the tank reaches full capacity, it automatically turn off the inlet valve to prevent overflow. The project integrates LDR sensor for light control, temperature sensor for climate management, and water level sensor for tank management. All controlled by the Blink IoT app. This setup allows for dynamic and automated adjustment of home environment condition, enhancing efficiency and convenience. So these are the project requirements which is done, which will be implemented by using these requirements. So let's talk about the peripheral required for this for the project. A temperature system which include a LM35, uh, a heater, a cooler, then LED, which is a light emitting diode for garden lights, then LDR, light dependent resistant, which is used as a sensor to detect the brightness of the environment. Blink IoT app for connectivity with mobile, then Ethernet shield, then Ethernet shield W5500. Then an I2C CLCD. CLCD is basically character liquid display. It will display the output which which is implemented by which is sensed by the temperature sensor and by the serial water tank. It will display a character liquid display uh, to print temperature and volume water tank with pin status of pins used to control temperature system and serial remote tank. Then this is the Pixim lab we have talked about. So it looks like this, a Pixim lab which contain an Arduino contain Atmega 328P microcontroller, and like we have like you have seen that these contain file, board, microcontroller modules, tools, help as options. By clicking that modules and going into the spare parts, you can implement, you can do the configuration for that Pixim lab. Uh, so this is how it look like LED. So this is look This is light emitting diode. It acts as a visual output device in home automation system, and it can represent various indicators or outputs such as garden lights. Typically connected to a digital output pin on the Arduino, which is like digital write. You can use digital write function to to toggle the LED or to on and off the LED. The LED's brightness is controlled by adjusting the duty cycle of PWM, which is none other than pulse width modulation signals. You can simulate different brightness levels by varying the PWM machines, which affects how bright or dim the LED appears in the simulation. For simulating garden lights, you might adjust the LED's brightness based on input from an LDR sensor, simulating how lights will dim or brighten dependent on ambient light condition. Though this is the LED. Then LDR, a light dependent resistor. It measures light intensity to provide input for controlling light related devices. It connected to an analog input pin on the Arduino. The LDR changes its resistance based on the light level. More light reduces resistance, while less light increases resistance. Means the resistance is inversely proportional to the light. Uh, the Arduino reads this change in the resistance as a varying voltage. This voltage is used to determine the light level, allowing the system to adjust the brightness of the LED accordingly. For instance, if the LDR detects low light, the system might increase the LED's brightness to simulate garden lights turning on. Then this is the LCD, character liquid crystal display. Displays textual and numerical information for user feedback or monitoring. It uses the inter-integrated circuit communication protocol, which requires only two wires, serial data and serial clock, which is none other than SDA and SCL for data transfer, along with power and ground connections. The Arduino sends data to the LCD using I2C commands, which control what is displayed on the screen. In your simulation, the CLCD can show real-time data such as current temperature reading from the LM35 sensor, the volume of water in the tank, and the status of various system components. This helps in monitoring and debugging by providing a visual representation of system states. Then this is the temperature system, which contain LM35 sensor, heater, and a cooler. It includes the LM35 temperature sensor, heater, and cooler. It measures ambient temperature and provides an analog voltage output proportional to the temperature, that is 10 millivolt per degree Celsius, connected to an analog input pin on the Arduino. The Arduino reads the analog voltage and convert it into a temperature value using a conversion formula. So this conversion formula is written in my coding part. Uh, I will explain the slide. Then heater and cooler regulate temperature by increasing or decreasing the ambient temperature. It is controlled by a digital output pin on the Arduino. Then based on the temperature reading, the Arduino can turn the heater or cooler on or off. For example, if the temperature exceeds 35 degrees Celsius, the Arduino will turn off the heater to avoid overheating. This system can also interact with the Blynk app to allow remote control of the heater and cooler as well as as well as to display temperature data. Then let's talk about the Ethernet shield W5500. Provide network connectivity to the Arduino, enabling it to connect to the internet or local network. Mounted on top of the Arduino and connected to the network via an Ethernet cable. This should uses the W5500 chip to handle network communication, allowing the Arduino to send and receive data over the network. Then project overview. This is a basically a representation, diagrammatical representation of how the project looks. Then it basically this is Blink. It contains an IoT Blink app, a mobile, a Pixim lab, and the home appliances, which I have explained earlier. So this is the code explanation. The Arduino Uno is widely used microcontroller board designed for prototyping and developing electronic project. It serves as the central control in various embedded system and DIY projects. So it contains Atmega 3285 as we seen earlier. It contain then 14, six of which digital IO pins 14, six of which can be used as PWM. Then it contains six. These pins can read analog signal from sensors. Then output pins, then communication interfaces, SPI, I2C, US power supply, USB power, external power, programming, USB interface, etc. So in this project, the home automation system is structured as follows. Various home appliances including garden lights, a cooler, a heater, and water tank valves are connected to the Arduino Uno. The Arduino serves as the central control unit managing these appliances based on the input from connected sensors and user commands. Specifically, an LDR sensor monitor ambient light to adjust the brightness of the garden light, while an LM35 temperature sensor measures the ambient temperature to regulate the cooler and heater. The Arduino is also linked to water tank system controlling inlet and outlet valve based on the water volume measurement. This setup is integrated with the Blynk IoT app which facilitates remote controlling and monitoring. The Arduino connects to the Blynk cloud server via an Ethernet shield W5500, allowing data exchange between the microcontroller and the app. So this is the code representation which contains an SPI.h, Ethernet, Blink Simple Ethernet, Wire.h, Liquid Crystal.I2C.h, which contain header files. SPI are included to enable Ethernet communication. The SPI library supports serial peripheral interface communication, while Ethernet handle network connectivity. Blink Simple Ethernet facilitates communication between the Arduino and the Blink Cloud Server via Ethernet, while Wire.h is used for I2C communication, allowing the Arduino to interact with I2C. So this is the code which is used for implementation. Then you have blink right, blink uh, digital, blink right heater pin, blink light inlet pin, then blink right outlet pin. We have function like this. Then we contain a function update temperature reading for updating the temperature, then handling temperature, then handling tank, then contain this contain basically void setup and void loop. The void setup it initializes the LCD, sets up the blink connection and initializes the LDR, temperature system and water tank system. It also sets up a timer to call update temperature reading every second. A loop it continuously executes brightness control, adjusts the LED brightness based on the LDR reading. Then temperature it reads the temperature, formats it to two decimal places and updates the LCD display. Then tank volume will read the current water volume and display it on the CLCD. Then blink dot run process incoming blink messages and update the blink app. Timer dot run execute scheduled tasks such as updating the temperature reading. Handle temperature it will manages the heater based on the temperature reading, and handle tank manages the water tank valves based on the current volume. This detailed explanation covers the code functionality, ensuring that each component and its role is in the home automation system. I'm not explaining each and every line of this code. So this is the final output of how the project look likes. So let me show the demo of the project. 1 second. Thank you. Let me show the demo of the project. 1 second. Where is my A power? First, let me connect the A power mirror to my mobile. Then I will do. 1 second. 1 second. Localhost. Mm, And sketch. Let's put on my right now. Then similar file loadex. Then loadex. Mm, this is connected. So let's start with the heater switch. Heater is on, so the value is changing 28.81, 29.30, 30.27, 30.76, 31.25. So after 35 degrees Celsius, it will get reduced. The heater button will stop. See 35.16, then it will go again decreasing. Then we will be controlling the inlet valve. See the water tank is connecting. So this is the demo for the project. Inlet valve. Outlet valve is connected. It is displaying, it also displaying the volume for that 24002360 and so on. So thank you.